I'm Richmond, and today we are on lesson 14, and our topic is on exponential equations. Okay, on exponential equations, all that I want you to know is that they are equations which have the variable or non quantity as index or exponent. So I want to give you an example on these exponential equations. So for example, if you have a, okay, let me change my ink to black. That'll be very good here. Okay, so let's assume we have a raised power x is equal to a raised power y, like this. And then because the unknown that we are dealing with, we are talking about x and then y. They are the unknown that we want to solve for. And then a are the base of this index. So whenever an equation is written in this form, we say that this equation is an exponential equation. So to solve this type of equation, we have to equate the exponent because the bases are the same. We now say that x is equal to y. This is all that we need to solve in exponential equation. One thing that you need to know in dealing with exponential equations is that write the equations in such a way that the left hand side and the right hand side have common bases so that we can equate the exponent. That's the key thing that we need to know. Let's take an example here and see how we can solve this type of exponential equations. First, we have 3 raised to power x. You can say 3 raised to power x or 3 to the power x equal to 9. So now we have 3 raised to power x and it's equal to 9. So we need to make the bases the same. So the bases should be the same. So we need to change 9 to an index. So we say that our 3x is equal to 3 raised to power 2. Because 3 raised to power 2 will give us 9 to be the same. So now we have the same basis. We can now equate the exponent. So we can now say that x is equal to 2. Very easy. Okay, so this is how we solve exponential equations. So we have to solve a lot of questions so that whenever you meet any exponential equation, you'll not find difficulty in solving them. Let's take our next example, and it's 2 raised to power x is equal to 8. I said earlier on that whenever you're dealing with exponential equation, make sure your bases are the same. So here the base here is 2, here we have 8 here. So we need to change 8 so that it will have the same base as 2. So we say that 2x is now equal to 2 raised to power 3, because 2 raised to power 3 will give us 8. 2 times 2 is 4, 4 times 2 is 8. So now they all have the same basis, which is 2 here and then 2 also here. So now because they have the same basis, we equate the exponent. We can now say that our x is equal to 3. Let's take the next example and see how we can also solve it. This one, the question is 3 raised to power x plus 1 is equal to 3 raised to power, okay, it's equal to 81. All right. So all that we need to know is that let's make all the bases the same. So 3 is already here, so we try to change 81 so that we have a base similar to 3. So now we come here and we repeat the same thing. 3x plus 1 here is equal to 81. 3 raised to the power what number will give us 81? And it's 4. So 3 raised to the power 4 will give us 81. And now, because the bases are now the same, we can now equate the exponent. Look at something here. Now, the exponent for the first base is x plus 1. And then the second exponent is 4. So we do what? We equate the exponent because they all have the same basis. Therefore, x plus 1 is equal to 4 here. And then we make x the subject. So x is now equal to 4 minus 1. And our x is equal to 3. Let's take another example and then see how we can solve further questions on this. Okay, our next question is, the question is, if 64 raised to power x, if 64 raised to power x is equal to 16, find x. What a very good question. Find x. So with this, what you need to do is that let's try and then change 64 to its index form. And then to change 64 to index form, we just need a number of times that we can multiply 2 to get 64. So we come and say that 2 raised to power 6 x, because 2 raised to power 6 will give us 64. But because it's the raised to the power x, the 6 will multiply the x which is already on top. I'm talking about this place. Now, a number to what number raised to power 2 will be able to give us 16. So you can see that 2 raised to power 4 is the same as 16. So it's equal to 2 raised to power 4. And then because now we have the bases be the same, base 2 here and then base 2 here, we equate the exponent. So we say 6x now is equal to 4. And then let's divide both sides by 6 to solve for x, because the first question said that we should solve for x. So divide here by 6 and divide this by 2 by 6. So 6 will cancel 6 and we'll have x equal to 4. X is equal to 4 over 6. But 4 over 6, 2 can divide 4 and give us 2, and then 2 divide 6 and give us 3. So x is equal to 2 over 3. Let's try another question. This is like we've been solving a lot. Let's solve a lot of questions here so that we will increase our understanding in how we deal with this type of exponential equation. This question is saying now find the true set of the equation. So our previous lessons we learned how we can find the true set of an equation. So this one, the question is 2 raised to the power x minus 2 is equal to 2. This one, they give a simple question and then we are expected to solve for find a true set. So with this, the bases are the same. And then yesterday our lesson, I told you that every number written without an exponent can be written in the form of raised to the power exponent or raised to the power 1 or exponent 1. Every number written without an exponent, we can write that number with the power of 1. So 2 here without an exponent means that it's having an exponent of 1 or power of 1. So when we are equating them, because they have the same basis, we say x minus 2 is equal to 1. And then we group like terms, so x is equal to 1 plus 2, because 2 now become positive and have our x is equal to 3. So finding the true set, we say the true set of the equation above is equal to this, put it in this bracket, x said that x is equal to 3, and we close the bracket. This is the truth set of the equation above. Let's take the next question and try and see how we solve it. This one, the question is 3 raised to the power 2x minus 1 is equal to 1 over 81. Okay, find x. Find x. So we are finding x in this equation. So all that we need to do is that let's find ways of making the basis the same. So find way of making this basis the same. We write 3 raised to the power 2x minus 1 is equal to 1 over 81. We can write it in the index form as 3 raised to the power 4, like this. Okay, so because now the bases are now the same, we can write this one this way. Minus 1 is equal to 3 to the negative inverse. So whenever we have 1 over an index, we can write that particular index in the form of a negative index. Okay, so here we are to equate our exponent because the bases are the same. So we have our 2x here minus 1 is equal to minus 4. Continuing, our 2x minus 1 is equal to minus 4. And then grouping like 10, you have 2x is equal to minus 4 plus 1. And then our 2x is equal to minus 3. Divide this one by 2, and we divide this one also by 2. Then our x is equal to minus 3 on 2. Okay, so thank you. That's the end of this tutorial.